In this video, we derive the equation of a hyperbola centered at the origin. To derive the equation of a hyperbola centered at the origin, begin with the foci. The foci are denoted -c, 0, and c, 0. We take a look at our figure to the right, and we see that we have one foci, -c, 0, and another c, 0. The hyperbola is going to be the set of all points x, y, such that the difference of the distances from x, y to the foci is constant. We can see in our picture these two distances labeled D2 and D1, the red lines. We have our arbitrary point x, y, and we see from that point x, y to one foci and then to the other. The difference of those two red lines labeled D2 and D1 will be constant anywhere on the hyperbola. If you have the point a, 0 as a vertex of the hyperbola, the distance from -c, 0 to a, 0 is a minus -c, and a negative times a negative gives us a positive, so that is a plus c. Similarly, the distance from the focus point c, 0 to the vertex a, 0 is c minus a. And the difference of these two distances is a plus c minus c minus a. And we can simplify that. We have a positive c and a negative c. They cancel each other out. And we have a, and we have a minus and a minus, so that turns into a plus. A plus a gives us 2a. If we choose some arbitrary point x, y on the hyperbola, we define those two distances, d1 and d2, as the distance from -c, 0 to our point x, y, and the distance from the focus c, 0 to the point x, y. By the definition of a hyperbola, distance 2 minus distance 1 is constant for any point we choose on the hyperbola, and it follows that distance 2 minus distance 1 is equal to 2a. Remember, the distance formula tells us that the distance equals the square root of the second x coordinate minus the first, quantity squared, plus the second y coordinate minus the first, quantity squared. So, inserting our two new distance formulas, we now have set equal to d2 minus d1 the square root of x minus -c, quantity squared, plus y minus 0, quantity squared, plus the square root of x minus c, quantity squared, plus y minus 0, quantity squared. Remember, d2 minus d1 equals 2a. And we begin with some algebra. We take the statement from the last slide, setting our two distances equal to 2a, and we begin. So our first step here is to write down what we start with. And what we've done in the second step, you'll notice, is we've added this term to both sides. So it moves over to our right-hand side and becomes a positive x minus c squared plus y squared. If you're wondering what happened to the minus 0, y minus 0 squared simply equals y squared, and so we'll forego writing those extra digits in. Moving on to the third step, we want to clear the square root from our left-hand side, so we square both sides, and that gives us x plus c squared plus y squared on the left. And the entire quantity here on the right is squared. Notice those braces around the entire quantity. The last step on this slide is to perform some foiling operations. So we FOIL, first, outer, inner, last, x plus c squared, which gives us x squared plus 2cx plus c squared. The y squared stays the same. And then we FOIL this guy out, and that turns into 4a squared plus 4a times the entire quantity square root x minus c squared plus y squared plus x squared minus 2cx plus c squared plus y squared. If you don't believe me, you can pause the video and take a moment and FOIL this quantity out. Starting with what we left off with on the last slide in bold at the top, some more algebraic manipulation. So you'll notice we have a 2cx here, and that's all we've left on our left-hand side. We have our left-hand side and our right-hand side. So we've left the 2cx, and we have subtracted x squared, c squared, and y squared from the left. So that means on our right, we have x squared, c squared, and y squared disappear since we subtracted them on both sides. 2cx is left on our left-hand side, and on our right-hand side we are left with the quantity 4a squared plus 4a times the square root of x minus c, quantity squared, plus y squared, minus 2cx. A little bit further with this, you'll notice now on the left-hand side we have 4cx minus 4a squared. And how we got there was we added 2cx to the right and 2cx to the left. 2cx plus 2cx is 4cx. And we subtracted 4a squared from the right and moved it over to the left. That operation left us with 4a times the square root of x minus c squared plus y squared. Dividing both sides by 4 gives us 4cx divided by 4 becomes cx. Negative 4a squared divided by 4 becomes negative a squared. And 4a times this quantity divided by 4 gives us a times that same quantity. Starting with that step, squaring both sides, we use FOIL over here, which gives us c squared x squared minus 2a squared cx plus a to the fourth. And again, take the time, pause the video, do some of these steps out, see that they really work. So we've changed our left-hand side, left the right-hand side the same. Now we're going to leave the left-hand side on this third line and move on to the right-hand side. We have a squared times this whole quantity ends up giving us a squared times the FOILed quantity, which is x squared minus 2cx plus c squared plus y squared. Moving a little further along, we notice once again we've left the left-hand side the same, and on the right we've distributed our a squared, giving us a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared on the right. And now we're going to work with the left again. You'll see we have a to the fourth power plus c squared x squared. So we added 2a squared cx to both sides to give us on the left a to the fourth power plus c squared x squared, and to give us on the right a squared x squared plus a squared c squared plus a squared y squared. We have a negative 2a squared cx and a positive, and that's what happened to that term. And we start again where we left off in bold at the top. And what we've done here is switch some of the order of these terms. C squared x squared came here. We subtracted a to the fourth from the left to move it to the right. Again, left and right hand sides of the equation. A squared c squared stayed here. Subtracted a squared x squared from the right to move it to the left, and subtracted a squared y squared to move from the right to the left. We factor out an x squared from these first two terms to give us x squared times c squared minus a squared. We leave a squared y squared alone for now. And on the right hand side we factor out an a squared from these two terms, giving us a squared times c squared minus a squared. And we have to watch out, we're going to make a variable substitution here. So we let b squared equal c squared minus a squared. Notice we have c squared minus a squared on the right and the left now. So we say that equals b squared. We plug b squared in wherever we see that, and that gives us x squared b squared minus a squared y squared equal to a squared b squared. We're almost there. We divide everything by a squared b squared, and this gives us x squared a squared. Those b squareds cancel out. Over here we have y squared b squared with the a's canceling. And this is a special form of 1. And we can see we are left with the equation of a hyperbola centered at the origin.